Let's move on. Congruent complements theorem. It says angles complementary to the same angle or to congruent angles are congruent. So 4, 5, and 6 are the three angles we're talking about. And we're trying to show that angles complementary to the same angle or congruent angles are congruent. That's what we're trying to make the statement there. If we say that 4 and 5 are complementary, then they add up to 90 degrees. If we're saying that 5 and 6 are complementary, then they add up to 90 degrees. And therefore, if 4 and 5 are 90, 5 and 6 are 90, take out the middle part using maybe the transitive property or something that sounds like it. We say 4 and 6 are congruent angles. Let's prove it. Okay? Fill in the blanks. First of all, given angle 1 and angle 3 are complementary, angle 2 and angle 3 are complementary, that's going to be our given. So G-I-V-E-N. Okay? First step. We're trying to prove that angle 1 is congruent to angle 2. So all the way on the last line, I'm going to make sure that that's the case. Angle 1 is congruent to angle 2. I don't know why, though, yet. But we'll come up with the reason and we'll prove it. We'll say it together. Okay? From before, if you look back up at your notes, up in this section, we talked about how our second statement is the definition of supplementary angles and what we wrote down. Turns out the same thing happens here. If 1 and 3 are complementary, then their measures add up to 90 degrees. If 2 and 3 are complementary, then their measures add up to 90 degrees. So we're going to say definition of complementary angles. Just like before, if the two angles add up to 90 degrees, then they must be complementary. So complementary angles will be our second reason. Now, again, like substitution, the third step in substitution, if you look up the page, it said that the third step, in supplementary angles, I'm giving the answer away. C is substitution for the same reason that C is substitution from supplementary angles. If you ask the right question of me, I'll probably tell you the answer without even knowing it. Keep that in mind. Okay, since 1 and 3 equal 90, 2 and 3 equal 90, let's just substitute, take the 2 down, and now we have 1 plus 3 is 2 plus 3, measure of angles. Again, the reflexive property comes up. From before, the reflexive property came up to say measure of angle 3 equals the measure of angle 3. Ha! Here it is again. The measure of angle 3 plus equals the measure of angle 3. Reflexive property. Again, it was used before to say, do we know if they're equal or not? We would assume so. We're not allowed to assume. Never assume. Prove. Okay? The measure of angle 3 equals the measure of angle 3 because of the reflexive property. Therefore, if I subtract both sides by the measure of angle 3, using the subtraction property of equality, you're allowed to abbreviate, by the way, guys. You are allowed to cut short what is said, provided that at some point I understand what it is what you're talking about. Again, if they're equal, then they are congruent. Definition of congruence. Okay, so we have the complements theorem, the congruent complements theorem. In this case, we're saying that angle 1 and angle 2 are the same size because they're both complementary to angle 3. That should make sense. If this is a 30-degree angle and 3 is the complement to angle 1, that means that 3 has to be a 60-degree angle. But if we also make the statement that 2 and 3 are complementary, if 3 is 60, then 2 is 30. Now compare their measures. 30 and 30, they have to equal each other. Therefore, we would assume that 1 and 2 are congruent. That's the idea. Okay, we're going to keep going on. We're now going to talk about vertical angles. So turn to the next page. This is page 2 out of the handout, and we will begin. In fact, I'm just going to keep on going. I have been stopping and pausing throughout the day. I'm here late. I need to go home. And to let you know, it's right now 9 o'clock. I'm working hard for you guys because I really care about you and care about your learning. So again, if you're not understanding this, come talk to me so I can learn how to explain it in a different way and help you out and help your brothers and sisters if they happen to have me as a geometry teacher in the future too. Okay, so let's move on. Let me secure my paper. I've been taping it down, kind of letting the cat out of the bag on how I've been doing this, but you probably be able to see from the marks over on the sides here. That's just so that I don't knock things out of place and have to go shuffling for it. Okay, I'm set. Are you set? Vertical angles, okay? Two non-adjacent angles. If an adjacent angle means they are next to, non-adjacent angles are not next to. They're formed by intersecting lines. We're going to need a ruler. So just like yesterday, where we had the ruler, let me find mine, where we had the ruler was meant to show us or give us a way to draw it really easily. It's not necessary too much other than to do this. Draw two intersecting lines. They have a common vertex, the angles do. The lines continue for forever. And they have the numbering scheme 1, 3, 2, 4. 1, 2, 3, 4. Okay? So let's start off with the example, a proof that uses the congruent supplements theorem. Congruent supplements mean if they are congruent or supplementary to a number, then another number that is another angle that is supplementary to this angle is going to equal the one across from it. All right, given angle 2 and angle 4 are vertical angles. Vertical angles are two non-adjacent angles formed by intersecting lines. Given that fact, what do we get to say? What do we get to say? Angle 2 and angle 4 are non-adjacent angles. Okay, this is by the definition of vertical angles. Okay, they form a linear pair. Angle 2 and 3 form a linear pair. Angle 3 and 4 form a linear pair. Why? Because look at the way they're created. They're on a line. They're an angle that comes off of that line, or a ray that comes off and creates two angles. So this is by the definition of linear pair. Same thing, 3 and 4. Here's the line that has angles 3 and 4 as a part of it. Here's the ray that separates angle 3 from angle 4. It's on a straight line. It has a ray coming off. That makes it 3 and 4 a linear pair. Definition of linear pair. Now the nice thing is, we have this proof. We have this proof that goes back to the previous page. If they form a straight line, they must be 180 degrees. If they're 180 degrees, they must be supplementary. So the measure, I'm not going to use measure, angle 2 and angle 3, and also angle 3 and angle 4. They are supplementary angles. Why? Congruent supplements theorem. Go back and read it. The congruent supplements theorem says angles supplementary to the same angle or to congruent angles are congruent. So therefore, angle 2 and 3 and angle 3 and 4 being supplementary must mean that, cross out the middle man, angle 2 is congruent to angle 4. This is a demonstration of the fact that 2 and 4 have to be equal. All we know is that they're vertical angles because they're on opposite sides. But now what we're given is that vertical angles are congruent. And we're going to use that fact that vertical angles are congruent. Okay? All right. I'm going to take a pause for a minute. I want you to make sure you've got this, and then we'll continue with the last page and a half.